Hello dear students, in this lecture I will be talking about review of basic statistical concepts. My name is Dr. N. Shah. In this session plan, we will be discussing about descriptive statistics, describing data by numerical methods. Under that, we will be discussing about various measures of central tendency. Then we will discuss measures of dispersion. Under that, we will be talking about variance and standard deviation. Then I will take up measures of shapes, and in that, I will be talking about skewness and kurtosis. Then I will be talking about probability and probability distributions, then sampling and sampling distribution. Then I will discuss about estimation, and finally I will be talking about hypothesis testing. So let us start. A basic course in statistics is an essential requirement for econometrics. This lecture will provide a review of basic statistical concepts that are needed as a foundation for econometrics. With these concepts, you will be able to do econometrics in a better way. The basic econometrics course starts with bivariate analysis, where all concepts of probability, probability distribution, sampling, and sampling distribution, confidence interval, and hypothesis testing are done on the bivariate or multivariate relationship. If a particular reader does not have knowledge of doing inferential statistics in case of univariate case, then that particular student is certainly going to struggle in basic as well as in advanced courses in econometrics. So to overcome this problem, one should first take a foundation course in statistics, and then he or she can go for basic econometrics course or econometrics 1. In order to address this particular problem in this video lecture, I will try to tell the statistical concepts in brief way. The following is the list of topics that will be covered in review of basic statistical concepts. First, I will be discussing about descriptive statistics. Descriptive statistics is nothing but describing data through, summary statistics or tables, graphs. Then I will be talking about probability and probability distributions. So you know that probability is nothing but chance of occurring an event, and there are various theoretical probability distribution relating to discrete random variable and continuous random variable. We will be discussing about these things in detail. Then we will also discuss about what is sampling procedures. Then the concept of estimation, and finally I will be doing about statistical inference. Now let us take what is descriptive statistics first. The knowledge of econometrics is given to students of economics to carry out research and modeling in economics discipline. Nowadays, R&D activities and publishing high quality research paper is very much required in academic career. In the ranking game, every academic institution wants to be in the top list, and research in quantity and quality matters. Let's consider any research paper. The results section generally starts with descriptive statistics of variables used in the study. So what is descriptive statistics? As I told you that descriptive statistics refers to those methods that help in describing the main features of data. So there are basically three techniques by which we do descriptive statistics. One is summary statistics. So these summary statistics summarizes data in single figure. And there are three summary statistics which are useful. So under measure of central tendency, so basically one of the uses of statistics, you can say, to summarize data, that is broad category of statistics, that is called descriptive statistics. Now under measures of central tendency, we are trying to find out where is the middle value located, or where what is the typical value in a data set. And under measures of central tendency, okay, there are three measures: mean, median, mode. Now which one is the best measure of central tendency? So the most accepted measure of central tendency is arithmetic mean. We also call it average, or simply mean, you can call it. There are, as I said, that there are three measures of central tendency: mean, median, mode. Now, which one, okay, we should use? Then, if your distribution, that is decided looking at the distribution of your data. If the data is normally distributed, then mean, median, mode all will be, one and the same. But if the data, let's say, is skewed, is not symmetrical, then in that case, okay, you can go for median. So mean is the average figure of a data set. Median is a positional measure of central uh, location, and mode is the highest frequency. Now coming to measures of dispersion. So what is, not only where the middle value is lying, but also what is the extent of deviation of a particular item from the mean value. Now this is nothing but measures of a spread, you say, or measures of dispersion. So there are many measures of dispersion, but the frequent used measures of dispersion are range, variance, standard deviation. Standard deviation is the most accepted measure of dispersion. Now coming to measures of shape. Now why this particular summary statistics is required? Because most of the statistical analysis is based on assumption of normality, normal distribution. Okay, so if the data is okay normally distribution, then you will find skewness as 0. So when skewness is 0, then your distribution of data, or frequency distribution, you can say, okay, is symmetrical when skewness is 0. And kurtosis basically refers to the pickedness of data. Okay, so for a normally distributed data set, the value of kurtosis is 3. So if skewness and kurtosis of any data set is different from 0 and 3, then your data is not normally distributed. Okay, another tool which is used for descriptive statistics is using graphs. For example, popular graphs which you can use in describing your data are bar graph, pie chart, and histogram. Then for showing some trend in a particular variable, you can also use line chart. Histogram is basically used to know the distribution. Okay, if it is normally distributed, then you will get a bell-shaped kind of curve. Then one can also use another technique which is used for describing data is table. So I think frequency table. For example, uh, uh, in class intervals, let's say marks obtained by 100 students. So number of students who have a score between 0 and 10, 10 and 20, 20 and 30, like this. Okay, these are called class interval, and let's say the number of students is called frequency. If you are showing this kind of information using some table, then it is called frequency table. And you can also find out relative frequency, proportion of students who have obtained, let's say 50% marks. So not only absolute frequency you can analyze, you can also analyze relative frequency. Then there is also something called 2 by 2 contingency table. Okay, so classifying objects based on two factors. For example, voted, not voted, and then male and female. Okay, so if you want to show this kind of information, then you can use 2 by 2 cross tabulation, or what we say contingency table. So these are the various techniques used for describing data. So I'm reproducing one typical uh, uh, descriptive analysis from a research paper. You can see here this particular research is basically from finance area, and here descriptive statistics of research variables are given here: price to book value ratio, then current ratio, return on equity, okay, size of the firm. And you can see here mean of these research variables are given here: mean, median, then minimum value and maximum value over the sample period. Then you can see here standard deviation is also given. So as I pointed out earlier, that to find where is the middle or centrally located value, you generally use arithmetic mean for that. And to find the extent of deviation from the mean value, the most accepted measure of dispersion is a standard deviation. Here range is not given, and also measures of shape, okay, uh, skewness and kurtosis are not given here in this descriptive statistics of research variables. This I am not going to discuss now, because I will discuss correlation and related concepts of correlation in a different lectures. Okay, fine. Now coming to probability and probability distribution. Here I have reproduced uh, Excel output of simple linear regression analysis. Why I am uh, giving this particular result here? My objective is to uh, highlight one particular thing. How to interpret this, and what is this basically, and what is this p-value approach of deciding whether a particular independent variable is statistically significant or not. So obviously, if someone is not having knowledge of probability and probability distribution, then uh, one will find it very difficult to interpret these statistics. Now, not only this, the lower 95% limit for this particular coefficient, okay, so you can see that the lower 95% figure is 9.82, and the upper 95% uh, figure is 27.67. Its meaning is that probability of lying this intercept between 9.82 and 27.65 is 95%. Okay, so there is only 5% chance that the value of population, value of this intercept term can go beyond this confidence interval. Okay, so obviously, while interpreting this particular thing, you require, basically you are interpreting in terms of probability. So that is why, probability and knowledge of probability distribution is very essential for doing econometrics. Likewise, okay. So what I am saying that without probability, sound knowledge of probability and probability distribution, sampling and sampling distribution, if you are doing econometrics, okay, then I would say that you are okay. You are not an econometrician, but you are a technometrician. Okay, you know how to run software, you know how to estimate model. Okay, but you are doing it mechanically without knowing certain things, so that is not desirable while doing econometrics, and that is why I am giving a review of basic statistical concepts in this particular lecture. Now, in order to interpret the Excel output, as I pointed out earlier also, you require the knowledge of probability and probability distribution, particularly for doing inferential analysis, for confidence interval construction, for model estimates and hypothesis testing. In fact, one of the crucial assumptions of the classical regression analysis is that the normality of random error term. One should be aware of normal distribution and standardized normal distribution before talking about normality of random error term. Probability, let me define it now formally. Probability is the chance of occurring an event. The probability of happening event A is denoted by PA. It is a numerical measure of the likelihood of occurrence of an event. Probability theoretically lies between 0 and 1. If the probability of an event is close to 0, then it indicates that there is less chance or degree of certainty that it is going to happen. Okay, so there is, however, if the probability is near to 1, then with a high degree of certainty, the event is going to happen. And this particular symbol, this is called probability of happening event A given the occurrence of B. So this symbol shows that probability of happening event A given that the event B has already happened. This is called conditional probability. Okay. Now some of you may recall this particular equation. Okay, this kind of equation we encounter in our first course of econometrics, and this is called SRF, or expected regression line. Expected value of y given the value of x is given by this equation. Although I am not given hat here, you can place hat in order to indicate that these are estimated value of alpha and beta. So this is nothing but conditional expectation, it is called. Okay, a concept derived from conditional probability. So this is conditional expectation of y given that the value of x is so and so is given by this line. Okay, or this is also called expected regression line or sample regression function. So if you don't have a knowledge of probability, conditional probability, then it's very difficult to understand or appreciate the basic idea behind econometric analysis. Now let us discuss one related concept, that is called a random variable. Okay, so we start from our simple linear regression model or classical linear regression model from this particular point. So in simple linear regression model, we have one dependent variable on the left hand side and one independent variable on the right side of the equation, and alpha and beta are the parameters of the model. Now you can see here that in the first equation, This is called deterministic model, exact model, or mathematical model. Now, what does it mean? Its meaning is that variation in y, variation in y is 100% explained by variation in x. So this is called deterministic model or mathematical model. This model says there is no other variable exists in this universe which can add to the explanation of dependent variable y. Okay. So, we have many principles, laws in exact sciences like physics. Okay. So E equal to mc square. E equal to mc square. This is called energy mass equivalence theorem. Okay. Where C is basically constant, E equal to mc square. So basically in this case, energy becomes function of mass and mass only. Likewise, here y becomes function of x and x only. Okay, but in economics, okay, or in management science, or in social science, or behavioral sciences, whatever you say, okay, we don't deal with exact relationship or mathematical models. In fact, we deal with this type of model. Okay, this model. So this model is, you can see that the difference between this and this is this random error term. Now this, in econometrics, we have a equation which is comprises of two parts. One is deterministic part. This is the deterministic part, and this is the random component part. So this model is called non-deterministic, inexact, or econometric model. Okay. So now what is this random error? Okay. Or before discussing what is this random error term or a stochastic error term, we want to know what is this random. Okay. What is random variable? So before discussing random error term, what is random variable, one should know. So random variable x, I am now defining what is random variable. Okay. So random variable x, let's say getting number of dots. Okay. So when we play, or throw a dice, okay, there are dots, 1 dot, 2 dots, 3 dots, 4 dots, 5 dots, 6 dots. So random variable x, let's say this random variable is nothing but getting number of dots, takes on some specific value with chance or probability. So random variable is nothing but random variable takes on some specific value with some probability. Okay. So this is the meaning of random variable. There are two types of random variable: discrete random variable and continuous random variable. Let us discuss what is a discrete random variable. It is that variable which can take on only a specific finite or infinite sequence of numerical values such as 0, 1, 2, 3. Okay. A discrete random variable jump from 0 to 1, 1 to 2, 2 to 3, etc. One important thing is that between 0 and 1, nothing exists. Okay. So for example, number of students in the class cannot be 25.5 because students can't be enrolled in pieces. It could be only discrete number, either 25 or 26. So this is called, random variable. So let's say uh, on a particular date, how many students attend class. So it's basically a random variable. Okay. Because we don't know exactly how many students will attend the class. Okay. So attending class is a random variable, and this variable assumes some uh, a specific value. Let's say 25 students will attend the class. With what chance? With what probability? That is the meaning of random variable. So a few more examples of discrete random variables are number of people going for a picnic, number of defective items among 1000 items inspected, number of smartphones sold in a week. Okay, so these are examples of discrete random variable. Now coming to continuous random variable, because these knowledge are important. Or why? Because accordingly we have a discrete probability distribution, okay, continuous probability distribution. So now let us discuss what is continuous random variable, which take on any value over a certain interval, such as, okay, a few examples of continuous random variable are measuring the size of the newly designed shoe, measuring the temperature of London on a particular day, okay, length of a bridge. So variables such as length, time, weights, voltage, marks of students are few examples of continuous random variable. While you cannot buy 1.2 smartphones, but you can buy 5.5 kg of sugar. So while the smartphone is an example of discrete random variable, buying some quantity of sugar is a continuous random variable. Okay. Now, before discussing, theoretical probability distribution, let us try to find the difference between, frequency distribution and probability distribution. So the concept which is related to the organization of data is called distribution. In case of data relating to samples, we have frequency distribution. The frequency distribution is an organized data of the observed values of a variable in the sample along with its frequencies in each interval. The frequency in each class interval is called absolute frequency. In addition, relative frequency gives the proportion of observations. In case of population, the concept corresponding to frequency distribution is known as probability distribution. Okay. The probability distribution describes each value of a random variable along with probability of its occurrence. Okay. So basically, probability distribution is basically a distribution of how a random variable takes some value with some chance or probability estimate. So probability distribution can be of discrete and continuous variables. Now let us discuss theoretical probability distribution. So these are four very popular, probability distribution: normal distribution, t distribution, chi-square distribution, f distribution. I am not going to discuss here, binomial distribution right now, or Poisson distribution or exponential distribution. So you people must be acquainted with this distribution, okay? And normal probability distribution, you please remember, this is a continuous probability distribution, okay? So let us discuss these important types of probability distribution. So normal distribution is the most widely used probability distribution in theory and practice. It is a continuous probability distribution. Many behavioral data can be well approximated by the normal distribution. So you please keep one thing in mind. So most of the phenomenon, whether physical, political, economic, social, most of the phenomenon can be roughly represented by normal distribution. This is the significance of normal distribution in statistical analysis. In fact, even today, 90%, more than 95%, you can say, statistical analysis is based on this Gaussian distribution, or what we say bell-shaped curve or normal distribution. So normal distribution refers to a family of continuous probability distribution described by this particular equation. Okay, this equation no doubt looks slightly complicated for those people who are not from uh, mathematics or solids statistics background, but this is a very simple equation. And if you remember, you know uh, please note down, this mu is nothing but mean of the random variable x. I hope now the meaning of random variable is clear to you. And sigma square is nothing but variance of the random variable x. And standard deviation is nothing but the under root of, you know, sigma square or variance. Phi is a constant 3.14, and E is also a constant 2.17, and this fx is nothing but height of the curve at particular value of the random variable x. Okay, and the value of x, these are the limiting values from minus infinity to plus positive infinity. So this is, mathematically normal distribution. Now let us look at the various characteristics of this normal distribution. So it is a bell-shaped curve. Okay. So bell-shaped curve means it is okay. I mean symmetrical around its mean. Okay. A total area of this curve is 1% or 100%. 50% is lying, okay, in the left tail, and 50% in the right tail. This is the meaning of, bell-shaped curve or symmetrical curve. So in this distribution, the mean, median, and mode are all equal. Okay. So this is an important characteristic. The tails of the normal distribution never touch the horizontal x-axis. It is asymptotic in nature. Okay. It is symmetrical around its mean value. The total area under the normal curve is equal to 1. Okay. Earlier I pointed out this. The normal distribution is defined by two parameters. So please keep this in mind. Two parameters, mean and standard deviation, okay, define normal distribution. Thus, once you specify the mean and the standard deviation, the above equation can be used to determine the graph of the normal distribution. While the mean determines the location of the center of the graph, the standard deviation determines the width of the graph. So let us look at, okay, look at the graph, how it looks like. So you can see here, this is a normal distribution, okay, graph, and between 1 plus minus 1 standard deviation, exactly 68% of the area under the curve lies between, okay, plus minus 1 standard deviation from the mean. Okay. So as I said that this distribution is defined by two parameters, mean and standard deviation. Approximately 95% of the area under the curve lies between plus minus 2 standard deviation from the mean. And approximately 99.7% of the area under the curve lies, okay, between plus minus 3 standard deviation from the mean. Now, this particular knowledge will help you in the construction of confidence interval. Okay. And as I told you that the total area of the curve is 100% or 1. Okay. So the values between plus minus 3 standard deviation from its mean value covers 99.7% of the observation. Okay. Now this is also called empirical rule, or 68, 95, 99.7 rule, empirical rule. It is clear that in a normal distribution, most outcome Okay, most outcomes will lie within 3 standard deviation from the mean. Okay, so this is the uh, you know features. These are the features of normal distribution, and this normal distribution knowledge is very useful in statistical analysis. Now there is a related normal distribution concept that is called standardized normal distribution and area under the curve. Now what is this? It is a special normal probability distribution with a mean of 0 and a standard deviation of 1. A normal variable can be transformed into a standard normal variable by the following formula. And this is nothing called Z test, or what we say Z score. Okay. So you can see here in this formula, X is an observation from the original normal distribution, and mu is the mean, and sigma is the standard deviation, okay, of the original normal distribution. The standard normal distribution is also called Z distribution or Z score. A Z score tells us the number of standard deviation a particular observation is above or below the mean value. Okay. A Z score is a unitary number which helps to compute probability because it cannot be calculated directly as they are expressed in different units. Thus, it is necessary to convert them into Z score first. I hope you know the significance of this standardized normal distribution now clear to you. Now, another popular distribution which is used in statistical analysis is students T distribution. Now, what is T distribution? The T distribution is employed when size of the sample is 30 or less and the population variance is unknown. Okay, so it is also called a small sample test, and when the number of uh, observation, let's say 12, 5, okay, or 20, then obviously it is less than 30 observation. Then obviously you have to go for T distribution, not Z distribution. Also, uh, when the population variance of population is not known, okay, irrespective of the size of observation, you have necessarily uh, go for T distribution. In fact, most of the software by default they provide T statistics. Okay, in fact, even in Excel, okay, they provide T values on the assumption of population variance is unknown. Okay, under this assumption all estimates are provided using T distribution. Okay, so for any random sample size of n drawn from a normal or approximately normal population with mean and variance, then T distribution is given by this particular formula. Okay. Now, where n is number of observation in the sample, mu is mean of the population, x is sample mean, and s is the standard deviation of population mean. Another related distribution is chi-square distribution. Okay, so you try to see the link uh, among these distribution. Let x1, x2, xn are normal and independent variables. If these variables are normalized, okay, by taking their respective standard normal values like this, okay, Z1, Z2, and Zn like this, okay. So starting from here, x1, x2, and xn are normal and independent variables. And if they are normalized, okay, like this, okay, and finally if we find, okay, summation of this, okay, a square of the summation of this, then it will give you chi-square distribution. So this is, chi-square distribution with n degrees of freedom, which is equal to the number of independent variables. Okay. So this is your chi-square distribution, and you will find chi-square distribution application uh, in case of, uh, significance test of independence one use, and also, in order to find goodness of fit test, particularly in, uh, you know, uh, business statistics, or simply foundation course in statistics teach all these stuff. So a goodness of fit test or independence test uses, uh, chi-square distribution. Fine. So here, another important distribution is F distribution. When two variables have independent chi-square distribution, okay. So all the four distribution which we have discussed so far here are somewhat related, okay. So when two variables have independent chi-square distribution, this and this, with, okay, n1 and n2 degrees of freedom respectively, then the ratio of this is nothing but F distribution with one n1 degree in the numerator degree of freedom and n2 degrees of freedom in the denominator. Okay, this is your F statistics. Now the F statistics usually involves the ratio of two independent estimates of variances, and uh, this is used to test the equality of two variances. So for this reason, the F statistics is often called, the variance ratio test, which is given by this. Okay. So F statistics is nothing but variance of sample 1 by variance of sample 2. Okay, with n1 and n2 degrees of freedom. You please remember that the F distribution has a skewed set. The value of F is always positive. If the F statistics is close to 1, then the difference between two variances is not significant. However, if the F statistics is large, then it indicates the difference between two variances, okay, are significant. Now, we have discussed a substantial part of our, review of our statistical concept. Now, we will be talking about inferential part. So the first topic which I'm going to discuss is sampling distribution. Suppose we want to find out mean time spent on a smartphone by people in a day in London on the basis of a sample of 100 people. Now the question is, how can I do that? So we can have an infinite number of samples, take different batches of 100 people from anywhere in London. Okay. Next, compute the sample mean from each sample. Okay. So you can have infinite, okay, subsample. Now, these values can be arranged in the form of distribution, which is called sampling distribution of sample mean. Okay, because for each sample, we will get one sample mean, sample standard deviation. Okay, so we will suppose I am having 100 samples, then we will have 100, sample mean, and distribution of these means is nothing but sampling distribution of the mean. I hope we got this particular idea. So likewise, if we use some other estimator, for example, median or mode instead of mean, then it would be called sampling distribution of a median or mode. Okay. Now, sampling distribution of mean. We know that sampling distribution of the mean is a distribution of sample means which is described by two parameters. That is, mean of sample means and standard deviation of, sample means. These parameters of sampling distribution are closely connected with parameters of the population through the central limit theorem. Now, the central limit theorem says that mean of the sampling distribution, okay, of the mean is equal to the mean of the population. Mean of the sampling distribution of the mean is equal to the mean of the population, and the standard error of the mean is equal to the standard deviation of the population mean divided by the square root of sample size n. Okay, so symbolically it is given. So this is mean of the sample means equal to the population mean, and standard deviation of sample mean is given by this particular expression. Okay, this is called a standard error. When population is normal, the central limit theorem says that sample means are normally distributed for any size of the sample. The sample means can be analyzed by Z distribution. If the sample means are normally distributed, the modified Z score formula is now given by this. Okay, so the standardized normal distribution was given by x bar minus mu by sigma. Now, in case of sampling distribution, it is given by x bar minus mu by standard error. Okay, so this is how we got the Z statistics or Z distribution. Okay, so sampling distribution of mean is given by this Z distribution. Now coming to estimator and estimate. In inferential statistics, a sample statistics is used to estimate parameter of the population. This process is termed as statistical estimation. Okay, so please remember, a sample statistics is used to estimate parameter of the population. So alpha hat, okay, tried to estimate alpha. Beta hat, okay, estimates beta, that is population beta. So basically, alpha hat and beta hat are sample statistics, and alpha and beta are parameters, okay, population parameters, you can say. Well, the statistic which is used to estimate parameter is called estimator. The value taken by the estimator is called an estimate. And there are two types of estimation: point estimate, interval estimate. Now, what is the point estimate? The point estimate is a single value. When we estimate population parameter by a single value, it is called point estimate. Example is, a company is interested in knowing what will be the average sales during Christmas in this year. Based on the past data, the R&D department of that company arrives at the conclusion that the average sales will be of $550 million, either mu equal to 550. This is an example of point estimate. The idea of interval estimate arises from the fact that instead of saying that the average sale will be $550 million, if the R&D department of the company says that the average sales will be between $500 and $600 million, then it is called interval estimate. Either the average sales, this mu lies between 500 and 600. So this is an example of interval estimate. Now you know that confidence interval are nothing but interval. Okay, confidence interval, from the name it is clear that you have attached some confidence to that particular interval. Now, what are the properties of a good estimator? So please remember that, okay, a sample statistic is used to estimate the population parameter, and this is called estimator. So what are the good properties, desirable properties of this sample statistics or estimator? Now, these are unbiasedness. What is this unbiasedness property of estimator? It's basically zero bias between expected value, okay, or you can say population parameter, okay, expected value and population parameter or true value, okay. Second desirable property is minimum variance. An unbiased estimator, okay, with minimum variance is, okay, uh, is desirable. Suppose the estimator is unbiased, but it is having larger variance compared to another similar estimator, then that cannot be, uh, you know, termed as a good estimator. An unbiased estimator with minimum variance is what we are looking for. Okay. Next is efficiency. Now, what is the meaning of efficiency? An estimator is said to be efficient or best estimator if it is unbiased and has minimum variance. Okay. So in this case, the estimator will be closer to the parameter value. Now, what is sufficiency or sufficient estimator? An estimator is said to be sufficient if it utilizes all the information contained in the sample. Now, here I would like to cite one example. For example, arithmetic mean. Now, arithmetic in the calculation of arithmetic mean, okay, every observation is taken into account, meaning information contained in every observation is utilized in the calculation of mean. However, in the computation of median or mode, every observation is not included. And that is why, median and mode cannot be termed as sufficient estimators. Fine. Okay, so in econometrics, we talk about something called blue based linear unbiased estimator. Now, this blue parameters are nothing but this based linear unbiased estimator. Okay, so obviously this particular parameter must have properties like unbiasedness, minimum variance, linear, and efficient. Okay, now one point I would also like to add here, these are the properties of small sample estimators. These are called small sample properties of estimator. Now, large sample properties, or what we say asymptotic properties, are the properties of the sampling distribution of the estimator, which is obtained from a sample whose size approaches infinity. Now, unbiasedness property when the size of the sample becomes infinity. This is called, asymptotic unbiasedness property. It is the same thing, okay? But in case of large sample, uh, instead of simply unbiasedness, here we have asymptotic unbiasedness property. Consistency is nothing but a parameter is consistent when it has minimum variance, okay? Minimum variance. And then uh, efficient, an estimator, okay, is efficient when n tends to infinity. So these are large sample properties of estimators. Okay. Now coming to methods of estimation, because in econometric analysis we encounter many types of estimation methods. So you can see from this slide that there are three different methods of estimation. Uh, Methods of moments. Two important moments are expected value and variance. Okay. Basically, methods of moments is linked with probability distribution. So in probability distribution, expected value and variance, okay, and in Bayesian regression, basically you will get, expected value, and a range of values you basically get. And two important moments used in Bayesian regression are expected value and variance, or a standard deviation, you can say. Another method we have for estimation of parameter is OLS, ordinary least square method. So in this method, what we basically try to do, we try to minimize the squared error uh, term. Okay, so in fact, this is the traditional or frequentist method to nowadays. It is called, this is called ordinary least square method. In fact, this is the most important tool in econometric analysis. And then we have what is called maximum likelihood estimator. So basically maximizing the likelihood, and particularly it is useful for in if you are conducting some logistic regression model, then obviously OLS is not applicable. You have to use what is called MLE, maximum likelihood estimator, or methodology of estimation. Finally, hypothesis testing. A hypothesis is a theoretical proposition that is capable of empirical verification or validity. It may be viewed as an explanation of some phenomenon or argument which may be true or false explanation. The purpose of hypothesis testing is to find whether enough statistical evidence exists to arrive at the conclusion that a belief or hypothesis about population parameter is supported by the data or not. In statistics, the stated hypothesis is called the null hypothesis, which is denoted by H naught. The null hypothesis is usually tested against an alternate hypothesis, which is the opposite of null. This is called alternate hypothesis, is denoted by HA. Okay. And while conducting hypothesis testing, you may commit two types of error. Okay. And this is the decision. Null is true, and if null is accepted, then you are making correct decision. Fine. If null is true, however, alternate hypothesis is accepted, then you are committing type 1 error. Okay. This is called type 1 error. Now, when alternate hypothesis is true, however, null is accepted, then you are committing type 2 error. If alternate is true and alternate is accepted, then you are making a correct decision. So these are the two types of error you encounter in hypothesis testing. Now, here I would like to highlight one thing, that if, let's say, type 1 error, committing type 1 error is denoted by alpha, and type 2 error, okay, is denoted by beta. Okay, then obviously alpha plus beta equal to 1. Now it's very difficult to find out which type of error is more acceptable to us. Okay, now you have to keep in mind, if you keep your type 1 error, that means alpha, when you set alpha at 5% level, then type 2 error will also get minimized. Okay, so this is important. Which type of error is important for you, more important for you, while making decisions. Now coming to what is the procedure of hypothesis testing. Now the procedure of hypothesis testing is given here. First step in the hypothesis testing procedure is to formulate the null and alternate hypothesis. The null hypothesis is basically, a negative statement most of the time. Okay, null means void empty. So for example, there is no relationship. Okay, when while specifying null hypothesis, let's say my null is there is no relationship money and happiness, and alternate hypothesis could be there is relationship between money and happiness. Okay, so this is how you can frame the null and alternate hypothesis. Now I have to test this hypothesis. So what is the type of error? Type 1 error I was talking about. What level of type 1 error I am ready to accept? So most of the time, this alpha type 1 error is set at, okay, 1%, 5%, and 10%. Now it's up to the researcher, okay, what level of type 1 error is ready to accept. Fine. But most of the time, decisions are made, okay, in every discipline at 5% level. In fact, Excel also provide estimates by default at 5%. And then, depending on the requirement, choose an appropriate test statistic, Z test, T test, or any other test, chi-square test, F test, okay? And then compute the value of Z test, T test, chi-square test, or F test. Compare the calculated T value, in this case, let's say, T value with the table value or either critical value, and take decision. And the decision rule is when the calculated T value is greater than critical T value, reject the null hypothesis. Okay. So this is how you will conduct hypothesis testing. Now, these concepts obviously help you in the econometrics 1 or in advanced courses of econometrics. If you approach basic econometrics course or time series econometric course, or let's say advanced courses in econometrics, or let's say panel data econometrics, whatever may be the level, these statistical concepts are core to the econometric analysis. And if you don't have this understanding of these concepts, it's very difficult to conduct a good econometric investigation. For economics and particularly those economics students who have taken econometrics course, I think this lecture will be helpful for them. And in this lecture, what I did, I have reviewed, those statistical concepts which will be useful for doing econometrics in a better way. Okay, thank you.